So good morning, everyone, and thank you for joining us today. My name is Eva Martin, and I'm part of ESA Corporate Communications team. We are delighted to have you with us today for this media briefing on the very special total solar eclipse that we will be experiencing this summer on the 12th of August. During today's briefing, we will talk about the eclipse itself, the science behind it, and how the European Space Agency will help audience experience this unique event regardless of where you are on Earth in that particular day. Before we begin, just a very brief housekeeping summary. Today's briefing is being recorded. We will make it available on our website afterwards, later today, hopefully. We will begin with short presentations from our speakers, and then we will open the floor to your questions. As always, if you have a question, you can either raise your hand or write it in the chat. And we will ask you, please, that when we give you the turn, if you can say your name and the media outlet that you represent today, that will help us very much. And if you already know that you want to direct your question to either me or Carol in particular, please say so. So it's now my pleasure to introduce you to today's speakers. We have here today with us Professor Carol Mundell, who is ESA's Director of Science and Head of ESA's European Space Astronomy Center in Spain, and Dr. Mijo Janvier, who is the Project Scientist for our missions Solar Orbiter, SOHO, and Proba 3. And with this, I'll hand over to Carol.
Thank you very much, Eva. And may I just ask colleagues online if you could please mute your microphones, because that will allow me to keep the noise off the line. Thank you. So we have a short slide presentation, again, which we will make available with the recording afterwards. So Eva, if you could please start sharing the slides, that would be fantastic. So as Eva said, we have a very special event happening that we will be preparing events around on the 12th of August in Spain. And today what we'd like to do is just spend the next 10-15 minutes or so taking you through what an eclipse is, why it matters, why we care, and what we're going to be doing this summer. Then we hope to give you plenty of time to ask your questions. I can see colleagues already still joining, so this is obviously a very popular media briefing. But let me go to the next slide and take us right back to basics, because before we start talking about the science, it's really good just to define actually what an eclipse is. An eclipse basically means something gets in the way and blocks the light of something from behind it. And the event that we're talking about in August is called a total solar eclipse. And the Earth, Moon, Sun system, we're quite fortunate actually that by happy scientific coincidence, the size of the moon relative to the distance of the Earth matches well with the size of the sun and its distance from the Earth, so that sometimes the moon gets into the path of the sun and the Earth and blocks the light from the sun. Now, the orbit of the moon around the Earth is elliptical, and it's also tilted slightly to the orbit that the Earth makes around the sun. And so this occurrence isn't very common. It's quite rare, and that's also why it's particularly special this summer. And you'll hear in a moment about other eclipses that are coming up in the next couple of years. So we have a lucky trio coming up. So what happens when the Earth is actually, the view of the sun from the Earth is blocked by the moon? And there are a number of things this lets us do. This actually lets us study the sun. Now, normally the sun is very bright. I will have a slide about safety, safe viewing of the sun. Obviously, you never look directly at the sun ever with your naked eye. But the point is that the sun, the photosphere, is a very bright part where you see the light coming from the sun. Beneath the photosphere is the chromosphere, and beneath that is the corona. And we don't normally get to see those unless we use special telescopes with special filters. But when the moon blocks out that bright light from the main disk of the sun, for a short moment, you actually can study very fractionally the chromosphere, and for a little bit longer, the corona. And Mijo will tell you a lot more about the science of that, how we study it from the ground and how we study it now from space, as we are now a spacefaring species. And the other thing that is rather lovely when you do have a solar eclipse, there's also a moment where the moon, which is not perfectly round and perfectly smooth, obviously it has craters, it has mountains, it has crevices, the light from the background sun can leak past the crevices and the craters and the moon. So we get what's called Bailey beads. So for me, it's not just a scientific moment, it's not just an incredible alignment of heavenly bodies, it's also a very human moment where for the first time, possibly, humans would have looked up and seen this phenomenon, but nowadays we understand what causes it. And it's a real human connection between us with our feet planted on the earth and the cosmos and the movement of the bodies in the solar system. So the eclipse on the 12th of August, it's actually around sunset, so that's a particularly interesting, also quite challenging time. It lasts about a minute and a half of the total eclipse, and then obviously there's a partial eclipse when you're further off the path of totality. It will be visible in Greenland, Iceland, Spain, and the north tip of Portugal. And there is a partial eclipse across the west, the rest of the Western Europe. So depending on what the weather is like where you are, you may actually be able to see a partial eclipse if you have the right glasses to view it. This is relatively short, a minute and a half, but it's enough to actually do some interesting things. So if we can move to the next slide, please, Eva, I'll just explain a little bit about what we have. So as I said, we have a lucky coincidence coming up the next 3 years. We actually have a trio of solar eclipses. So in the top panel on the right-hand side, you can see the one that we're talking about for this summer. You can see the path of totality there coming across the north of Spain there, and you can see the wider partial eclipse. Next year, on August the 2nd in 2027, we'll have an eclipse that lasts a bit longer. It's about six minutes, and it just covers the tip of Spain and into North Africa. And then in January of 2028, we'll have another one. So next slide, please. So let's focus on this summer. So I'm hoping that you will be able to join us from wherever you are. ESA is actually organising 2 main events. The first one, of course, is our international live broadcast, and I'm immensely pleased and privileged to have Dame Dr. Maggie Aderin, who will be hosting the programme. I will be helping her with that and some other special expert guests. We will be streaming this live on ESA Web TV and YouTube. And so wherever you are, we hope that you will be able to enjoy the experience of the eclipse, some of the science around it, and learn a little bit more about the observatory in Teruel, where we will be broadcasting from. Okay, I see Eva's saying there are some audio issues. Maybe I should stop Eva.
Carol, I think
that's fine.
Go on. I think because everyone else I check it's working, so I'm just checking with Virginia if I can help her.
Okay, that's fine. And we'll have the recording available, obviously, afterwards. So this will be streamed live. We'll be beginning about an hour before the eclipse and running through it and after it. This will be actually the first solar eclipse I've ever seen, so I'll be really excited to observe this. And we'll be bringing you lots of science and commentary and taking you through that. So as I say, that will be live broadcast wherever you are, so we'll be able to share this internationally. We realise everybody can't come to Spain to have an in-person experience. But in parallel, we will also be having a large public event in the town of Lyon. This is a free public event. It's organised by the University of Lyon and the City Council, supported by ESA, bringing the science of the eclipse closer to the public. So we're expecting a large turnout from the public there, and so I think there will also be that sense of collective observing, which I think will also be very moving. There will be talks by ESA and partner experts, hands-on workshops and educational activities, and there'll be live connections to our ESA international broadcasts, and we'll get a real sense of the atmosphere over in Lyon. And all the activities there will be in Spanish. The international live broadcast will be in English. So I hope you will join us either online or in person. And I'm also referring on the left-hand side, if you want to read more about this, you can go to the ESA webpage and see that item there. Next slide, please. So I said it's important to obviously observe safely, and obviously I always repeat this whenever we talk about the sun: never ever look at the sun with your eyes, never look at them through binoculars or sunglasses. You should never look directly at the sun. That's the first important thing to remember. And you can see here a number of safety tips. Again, we'll be making these available on our web pages. So please, wherever you are publishing or broadcasting, it's really helpful if you can pick up some of these key safety messages. particularly the use of mylar glasses, which is the only type of material that you can safely observe the sun through, particularly if it's a partial solar eclipse. And so we do ask you to share these safety messages because I think this is very, very important. Again, we will share these details, the do's and don'ts of observing the sun, and also some easy ways if you don't want to if you don't have the right equipment, for example, to project the sun onto paper or onto a wall or wherever you are. So simple ways that you can actually experience this but safely. Next slide, please, Eva. And then more broadly, we have prepared a wide range of educational resources. Again, would be great if you could share this with your audiences. So lots of things for families to do, for schools to do. Again, we will share the links for these with you. So we have an Eclipses educational kit. Lots of information about what eclipses are and why we care, what they're important for, how they work and how you can observe them. So there's lots of some background information there, and you can go and pick all of those up and share those with your audiences. So really we want the public to be involved. We want people to share in this experience and to really have a visceral personal experience connecting to the cosmos. Next slide, please. And then before I hand over to Miho, I just wanted to kind of put this into a wider context because, of course, humanity has observed the sky for thousands and thousands of years. The study of the solar system, the study of the cosmos, of course, has led to the discovery of the fundamental laws of physics that govern our everyday lives now. And really, it was not always a happy experience to think about being excited about a solar eclipse. You can see one of the pictures here. One of the beliefs used to be that a cosmic dragon was eating the sun. So obviously, many years ago, there was a time of fear. A lack of understanding. Why has the sun suddenly gone dark? The sun, of course, providing life and illumination and energy and helping crops to grow. So the sun was really seen as a fundamental part of survival. And of course, when the sun suddenly goes dark without explanation, that must have been a rather terrifying, alarming thing for the peoples of the day. But really through scientific study, philosophical thought, observational experiments and the development of modern technology, we now understand a huge amount of the sun, and this is why we can share this with the public without fear or trepidation. And of course, blocking out the light of the sun not only lets you study parts of the sun that you couldn't normally see when you're dominated by the bright light of the photosphere, but it also lets you study the night sky behind, which is not visible during the day. And of course, in the bottom right-hand corner, there was the iconic experiment when Arthur Eddington took an expedition down to the Principe Islands with photographic plates and used the total solar eclipse of 1919 to study the stars in the sky that were visible the minute that the bright light from the sun was blocked out. And by doing that, he was trying to measure the deviation of the light or the disruption, the bending of the light past the sun, which is caused by the deformation of the gravitational potential, which was predicted, the amount of deviation was predicted by Albert Einstein's general theory of relativity. And of course, Arthur Eddington had a tough time getting there, but he managed to make one observation. He had clouds, he had various challenges along the way. It was not easy in those days to make that expedition, but he had one photographic plate that he claimed confirmed Einstein's general theory of relativity. So of course, he brought that news back and that went around the world, and you can see the newspaper headline in the bottom right-hand corner from the New York Times at the time. The men of science, men, I note, mostly agog, and the stars not where they should be, but people should not be alarmed. So it was a huge revolution in physics. The testable prediction confirming Einstein's general theory of relativity. So there's a lot to think about in solar eclipses, and I will now pass on to Miho, who will bring us right up to date and tell you more how we know more about the sun, what the science of the sun is, what we're trying to understand more generally with our missions, and why this solar eclipse is exciting and what we're going to be doing this August. Thank you for your time, and over to Miho.
Great. Hello, everyone. If the video can be played, the first one on the left, what I want to show you is that what you see during a total solar eclipse is actually the sun's atmosphere. So our star, like our planet, has an atmosphere. And as you can see in the video, it's actually quite dynamic. It's very structured. And it's structured by its magnetic field. Think about the star as being a giant magnet. And what you see around that really is tracing these structures is basically the sun's material that we call a plasma, which is a really, really hot gas. And this doesn't stay within the confine of our sun. This material and the magnetic field actually expands all the way to the boundaries of the solar system. So here on Earth, we are protected by our own magnetic bubble, but Earth and other planets of the solar system are actually embedded in this whole magnetic field that is emanating from the sun. So we're really interested in understanding the variability of this atmosphere. We have short-term variability in the presence of big explosions that are happening in the sun's atmosphere, what we call the corona. You may have heard of solar flares, and it's been a really hot topic in the past couple of years due to the fact that these flaring activities actually have an impact on Earth. You can see this in the presence of northern lights and southern lights. I had the opportunity to put a really nice picture taken by our ESA astronaut currently on board the ISS, Sophia Deneau, who took this really magnificent aurora. But it also has some importance in terms of impact on our human technology and society in general, as it can impact our satellites as well as even electricity grids. So we're really interested in the short-term variability of the sun, but also this constantly and continuously emanating particles, material, and magnetic field from the sun's atmosphere in the shape of what we call the solar wind. And the solar wind can also have impacts on the sun-Earth system. Indeed, it can also create some what we call geomagnetic storms that will create northern light, but also affect on our human technology. I talked about the influence of the sun's atmosphere all the way to the boundaries of the solar system. And we also see this long-term variability in the shape of what we call the solar cycle, which is around 11 to 13 years. And that will indeed also have an effect on, for example, the amount of cosmic rays that we receive here on Earth. So for all of these reasons, while we are interested in understanding how the sun's atmosphere behaves, how dynamic it is, what are all these structures that we see, and eclipses are really a good time to see that. So what you see on the right-hand side is an image of a really nice eclipse that has been taken from the ground, where you see the structure, the structures, kind of rays that are coming from the sun, but much further away than the picture or the video that you saw on the left. And the reason is because we have really covered the surface of the sun that is extremely bright in order to make appear this halo, this corona that is the sun's atmosphere, and that really expands very, very far away. So in order to do that, we cannot wait for natural eclipses that we see on ground in order to do research. So that's what we need to create artificial eclipses. And in the next slide, you'll see that the European Space Agency has the capability to do that with 3 different spacecraft. We have the first spacecraft, Solar Orbiter, that was launched in February 2020, and that has on board a lot of different instruments, including a telescope that allows us to do artificial eclipses. We call that a coronagraph. And what it does in the video that you see at the bottom is that it hides the light that comes from the disk, from the surface of the sun, so that it allows us to see what happens around and see especially those big structures that sometimes emanates when we have flaring activity, what I like to call solar storms. We also have another mission called SOHO that was launched more than 30 years ago now. And so SOHO has the great capability to monitor continuously the sun and the sun's atmosphere and show us how the solar storms have been evolving over time, so over 30 years. It's basically a treasure trove for us scientists to understand how they propagate, how often they occur. And these data are actually used by national assets in order to predict space weather. So what is going to be the impact of the sun's activity on Earth within sometimes a few minutes to a few hours or days. And the last one is kind of the new kid on the block. Proba 3 is more of a technological demonstrator, but that has some scientific value because it has on board a chronograph as well. This is a technological demonstrator in the sense that it's actually 2 spacecraft that are flying information One, the one that you see on the right-hand side, is the occulture. So it will basically pass over the sun a bit like what the moon does in order to shadow the sun. And the spacecraft on the left-hand side, we call the chronograph spacecraft, has on board a telescope that will capture the corona, so all the atmosphere that you see of the sun. So all of these missions are different in the sense that they are positioned in different places in the solar system. So Proba 3 is orbiting around Earth. SOHO is between the sun and Earth, so much closer to us in this point of equilibrium, of gravitational equilibrium that we call the Lagrangian point 1. And Solar Orbiter is actually orbiting on its own orbit and getting closer to the sun as we have ever been with telescopes. So it's actually 1/3 of the Sun-Earth distance. And by doing so, we actually have exquisite details of the corona, of the sun's atmosphere, that allow us to understand, again, how structured this corona is. How can we accelerate the solar winds? Why are solar storms propagating in the way they are? What are their structures? And can we actually have models that can predict them? So these are the kind of science that we do with those artificial eclipses. But of course, coming back to what's going to happen on the 12th of August, in the next slide, you're going to see that we are also interested in what happens when we have total solar eclipses on the ground. And the reason for that is that we have really complementary data sets that we can collect on the ground. So we do have eclipse teams that are going to follow eclipses as they occur regularly on Earth. So what we can do is we can have different wavelengths that allows us to complement the large data set that we collect with our different spacecraft. But what we also do is prediction. So this is an example that I wanted to show, where, for example, for Solar Orbiter, we're going to start preparing for the total solar eclipse weeks before. So we're going to start around now. We're going to take data of the sun's magnetic field that we can collect at the surface of the sun. These data are taken by international teams that are going to feed them into computer models and try to recreate the structure of the corona. So in what way the corona is going to behave and what is going to be the shape during the total solar eclipse. This is kind of a game to show how good our models or how bad our models are in order to understand whether we really do have the good physical ingredients, the right physical ingredients in our models currently, and we're going to use the total solar eclipse images that we're going to collect in order to check whether we are doing well or not in terms of predictions. We have dedicated programs for Solar Orbiter, I just said that. SOHO has 24/7 coverage, and Proba 3, we also have observations planned during that time. And the great thing is that because we have different angles of observations, for example, Solar Orbiter is going to be as seen from us to our left, we actually have different ways of looking at the sun with different viewpoints that allow us to do a 3D reconstruction of the whole corona. So that's a really, really exciting time. Not only can we do that on grounds, I highly recommend you to have this extraordinary experience of looking at total solar eclipses, but just know that we're also going to monitor the sun with our spacecraft capabilities. So yeah, I hope that that inspired you to spread the word about the great science that we do, as well as the exciting time ahead that we have with the 12th of August total solar eclipse. Thank you.
Many thanks, Carol, Mijo. We will now start our Q&A session. We will take as many questions as we can now. If there are questions that we cannot take because of time, please send them to us and we will back to you as soon as possible. I can see Marcia has her hands raised. Marcia, if you can please unmute yourself.
Yes, hello. Can you hear me?
Loud and clear.
Yes. Oh, wonderful. Good morning on a very early morning here in Cape Canaveral. I'd like to hear more about Proba 3, what it is actually going to be doing during the eclipse, and how many artificial eclipses have you created so far? I know there was a little snag in the mission, and I'm assuming that's all fine and the spacecraft is working fine again. So just a rundown on what it's been doing, how many eclipses, and what exactly it's going to do. And are there any, during some of the US eclipses, NASA launched balloons from, with, sensors and cameras. What ground scientific studies will be going on during the eclipse? Thank you very much.
Sure. Yeah, thank you so much for your question. So indeed, just for context for other people who may not know so much about POBA3, as I said, this is really a very interesting time that we are at, where we can fly to spacecraft information. One is really occulting the sun, and the other spacecraft is taking data of the corona, of this halo that we have around the sun. And during those times, so what is important to understand is that even though we have those chronographic capabilities on other spacecraft, the capability that we have with POBA3 with this formation flight is that we can get even closer to the surface of the sun. So we're not exactly at the surface of the sun. We are around what we call around 1 solar radii. So we are really close compared to others that are more at 3 solar radii. And we can really capture the beginning of the propagation of the solar wind. And one of the really interesting recent results that we found is that the solar wind is actually much faster closer to the sun than what we thought it would be. So there are all these questions that come up where, why do we have this acceleration? And is it the same in any regions of the sun? Do we have preferential regions where this solar wind, this constant emanation of particles, the magnetic field comes from? But we're also at an interesting time in the solar cycle where we have passed the peak of the solar cycle, but we still have a lot of these structures that you may see if you do see the total solar eclipse with the naked eye, what we call prominences, that are structures that are kind of suspended in the sun's corona. And with POBA3, because we're really getting closer, we can really see those formed structures that are suspended. And if we're lucky, we may also see some dynamics and see them coming out. So during the solar eclipse, so starting from June, so when we recovered capability to do observations, we have those regular artificial eclipses. And the idea, again, is really to do complementary observations. So we have those like normal operations where we look at the sun's corona, but we want to have that at the time, or at least the closest that we can of the eclipse, because all eyes are going to be on the sun. And as I said, we're also going to be observing in coordination with solar orbiters, so with another view angle, and that gives us an idea of the three-dimensional structure of the corona as well as the structures. And this we cannot do all the time. So we really have to have those nice alignments, whether it's a total solar eclipse that we can see from the ground, the alignment with the different spacecraft that allows us to have like the best data set at the right time. So this is what we're going to do during the 12th of August. I hope I got, I think there was another question about how many eclipses. So we have around more than a few hundreds of artificial eclipses done with POBA3, but of course this is including, so not including all the artificial eclipses that we have with solar orbiter. So in terms of how many eclipses that we have for solar orbiter and SOHO, we count them in terms of days, and at this stage with SOHO, it's years of artificial solar eclipses, and for solar orbiter, it's around the same due to constantly monitoring the sun.
Thank you, Miho. Hey, Marcia, have we answered all your questions?
Oh, any science experiments conducted from the ground, perhaps in Spain or even Iceland, Greenland?
So in terms of, so they are solar eclipse teams that are conducted by solar physicists. Indeed, from Spain, I'm not sure which one. So I'm not in direct contact with those teams, but I know that regularly within our community, there are some expeditions, some solar eclipse expeditions that are organized. In the case of Ireland, I know that we had the potential opportunity to fly the spare of our chronograph on POBA3 on an Irish flight, but in the end, our spare flight is going to be in Spain observing. Maybe one thing that I want to highlight is that indeed solar eclipses are a really good time to test instruments as well. So not only do we collect science data, but it's also a really good time to test instruments. So I know of, since we're based in the US, that we also have some colleagues in the US that have flown some instruments in order to test them ahead of rocket launch, or ahead of, even in the future, have them on actual spacecraft. At this time, for the 12th of August, I am not in contact with our science colleagues that would be doing this.
Thank you, Miho. Marcia. I believe we have another hand raised. You have Tobias Meyer.
Yes, thank you. It's Tobias from Austrian Radio and TV. My question would be, could you describe how the solar eclipse will look like in Central Europe, particularly in Austria?
Would I take it, or Carol, do you want to talk about the partial eclipse? Or
Sure, Mia. Yeah, I'm happy to take this. So you won't have totality over in Austria, but if you see the slide that I showed where you see the path of totality, and then there's another picture there that shows the partial eclipse. So you will definitely have to have the special mylar viewing glasses, because obviously the sun will look normal in the daytime, but of course when you look at use the mylar glasses, you will actually see the shadow of the moon partially occulting or taking a bite out of the disk of the sun, if you like. So it's really important to use the mylar glasses. You may, depending on if there's no cloud cover in the sky at all. I mean, certainly when I've experienced partial solar eclipses, you get the sense of a slight dimming, but again, because it's also at sunset, that will probably be less obvious. But particularly with the mylar glasses, you'll actually see the moon there covering part of the solar disk.
And one thing that I would add, if you can encourage your readers or your public, is that if you do not have glasses, so sunglasses, what you can do as well is you can create your own pinhole camera, and that's really, really easy to do. You can do that, for example, with a piece of paper and with a sharp pen or pencil. You can just create a little hole. You can even create like multiple holes, and by projecting the sun on a surface, you can actually see the evolution of the partial eclipse, and it's really fun to do with, for example, kids. They love doing that. Another thing that you can do if you have that in your kitchen is with a colander, and it creates like a myriad of partial eclipse, and that's really fun to do as well.
Thank you. Thank you.
Many thanks both. We do have a question in the chat from Niam Show from the Irish Times, who is asking, as part of your live stream, will you be checking with other countries across Europe experienced partial eclipse who are also hosting watch parties? And a second question for my family watch party, will ESA be sending out eclipse glasses for the official watch parties across Europe? And if so, how can we acquire them? If maybe I can help with the second question in this.
I was going to say, yes, I know we've had a lot of demand for our ESA glasses. We've been distributing many of them. I'll certainly hand that second part to you, Eva. And yes, thank you, Neem. We are obviously, we have a number of broadcast sites that we will be pulling from for the live broadcast, particularly to make sure that we also have some redundancy. We're hoping for a clear sky. I mean, there's no reason not to have a clear sky in Spain. There are many other locations where it's possibly going to be cloudier, but again, we have some backups because we want to make sure that we will guarantee to have something to put into the live stream. But yeah, we're certainly drawing from other sites. For the partial eclipses, again, I think that's something that we're focusing mainly on the totality, because that's the purpose of the international broadcast. Partial solar eclipses are a little bit less rare, and so more people may have had the opportunity to see those in the way that Miho described, projecting through colanders or pinhole cameras. So we will be focusing on the streams that will give us the totality if we need to draw from those. We'll also be hoping to ping up from Leon, as I said in my opening remarks, to get that sense of wonder from the crowd in Leon, so we get a real sense of community and how people are experiencing this.
Thanks, Carol. I will also add that we are also sharing our signal from Havalambre with many different partners in case weather is actually cloudy, so they can also take on our signal as well in case the public event doesn't, which hopefully won't happen, and everyone will have a very sunny and clear sky that day. On the glasses, unfortunately, Niam, we are sharing glasses in our public events, in the ones that we're current. We are also sharing glasses with some museums across Europe, so they can hand them in with people attending their premises. But that is not the case everywhere and with everyone. But the very important thing is that they are certified glasses and that you watch these safely, I would say. I don't see more questions at this moment on the chat or any hands raised. Sorry, we do have some. Angelica Kren has been the first one to raise her hand. Angelica, if you could.
Yes, hello, can you hear me?
Yes, we can.
Hi, I am Angelica from Swiss Radio and TV. I have actually two questions. Could you please elaborate a little more with which instruments exactly you are going to monitor the eclipse on Earth? And what will you do? Which experiments will you approach with these instruments? The question is the main goal to collect data and to check your models, or do you have any other questions answered? And also you mentioned that eclipses can be used to test instruments for space flight. Could you elaborate on that? What exactly is tested? And yeah.
Sure. Yeah, maybe Miho, I can take a broad comment first of all, and thanks for your question, Angelica. I know there are a number of citizen science projects that will be dedicated to this eclipse. So it's not just observations of the sun. I know people are interested in measuring the temperature where they are, you know, bird song. I mean, all of those sorts of natural responses to the solar eclipse. From the ground as well, there are many observing groups who have solar telescopes who, when there is not an eclipse, they're able to use things like hydrogen alpha filters. So they're actually able to look at lines that come, spectral lines, so particularly tiny parts of the electromagnetic spectrum produced by elements in the sun. And so we're able to do that from the ground. And then, as Miho said, it's that, first of all, there is the three dimensions. We have the ground, which is the Earth as a telescope, if you like, and then our satellites, which are distributed at significant distances, different distances. So we have that unique three-dimensional combination in real time, and then obviously how that changes with time. But Miho can talk a little bit more about the actual detailed instruments that we hope to test as well.
Yes, and just to come back to part of your question where you talked about predictions, this is really, really interesting. And this can be done on ground as well as on our spacecraft. And this requires a little bit of preparation. So as I said, these are activities that are going on that have started, but that are really going to ramp up. And the idea is to really measure the magnetic field of the sun, so we can do that on the surface of the sun. So the problem that we have is that we only have an idea of how the magnetic field is distributed on the surface and not so much in the corona. It's extremely difficult to measure that in the atmosphere because it's such a non-dense, tenuous medium. And so what people do is that they measure on ground. So we have that also with large ground-based observatories that are in the Canary Islands, in Hawaii, etc. So we've got those infrastructures that allow us to really monitor the sun's magnetic field. And these are fed into numerical models that we have with computers, where we have physical ingredients that allow us to reconstruct in three dimension what the magnetic field and ultimately what's the material that is embedded in this magnetic field is going to look like. And so just to repeat what I said during my presentation, in case that wasn't clear, is that currently we have those models, but we need to test them. So we are always trying to improve and always trying to get the best physical ingredients in order in the future to have the best model, especially a dynamic model of the sun's magnetic field. So in order to test that, what we do is we take those measurements that are taken from the ground. So mostly these are done by ground-based observatories, but actually even the normal citizen who has a telescope can do that with special filters. And we take these measurements again to reproduce the magnetic field, create synthetic images, so fake images of the sun. And then during the total solar eclipse, we can take images of the total solar eclipse. So this in what we call white light, the normal light that we can even see with our human eyes, and compare that. And by comparing the structures, we can see whether do we get things completely wrong or do we get things right, and where do we get things right or wrong in order to fine-tune our models for the future. And then there are complementary activities. So we talked about testing instruments. So these can be technological demonstrations. So really understanding how we can make, for example, faster instruments or fine-tune certain instruments given certain wavelengths. And what we do is we generally, because it's way too expensive to send something that we don't know it's going to work in space, we do all the testing on the ground. So we really build the instruments and we fly them on special flights that allow us to test whether technologically the instrument is ready and whether it makes any scientific sense. So can we get more understanding by looking at, for example, this wavelength or that wavelength? And once this is kind of approved and we see that, okay, there is a scientific how to do that, an endeavor to have this instrument, then it can go into a whole process where it's tested on rockets, so what we call sounding rockets, and then later on can be proposed as a new instrument on a space mission. So again, total solar eclipses really give us the opportunity to do that. So I hope I replied to that question.
Yes, you did, but maybe for me it's not totally clear. Why can you test your models only during a total eclipse? You could measure the whole winds and everything without the eclipse and compare it to your models, couldn't you?
So on the ground, it's very difficult, and the reason is because we can of course look at the sun all the time, but the sun, the surface of the sun is so bright that we cannot actually see that much of the sun's corona, this atmosphere. So we have to create those artificial eclipses in a way, or to wait for a total solar eclipse to really have a really nice coverage of the sun's surface. So of course we can also create artificial eclipses on the ground. That's actually the whole idea of coronagraphs on board space stations comes from what has been done on the ground actually by a French astronomer called Bernard Liot. The problem is that we don't have the capability to get really close to the sun due to the light that is scattered basically by the sun's surface and really close to the surface. So we can get an idea of quite far away, but total solar eclipses, as they are now, because of the nice coincidence that we have of the moon's size that perfectly covers the sun's surface, we can really get really close to the sun, and we can only do that on the ground with total solar eclipses. And we only have these moments in time to do that.
Thank you. I think I understand better.
Thank you.
Thank you.
Many thanks both. Second person to raise her hand, Zulfikar Abani. Hello, Zulfikar, can you hear us?
Hear you. I'm just trying to work out the permissions here in my program. Thank you very much. Yeah, Zulfikar Abani from DW, Deutsche Welle in Germany. Thanks very much for the actually really multifaceted presentation. It's been really useful so far. Thank you. I also have two questions. I'll keep them brief. So if I'm not mistaken, this is the one on the eclipse on the 12th of August is the first in 100 years around the Iberian region. It reminds me of a London bus. You know, you wait all this time and then three come along. So what explains the fact that there are going to be three events in this particular region in a relatively short space of time? I know it covers 3 years, but actually it's, what is it, 18 months or something like that? And the other thing is, what can you tell us about, so what explains that, if there is a particular explanation for that, an astronomical explanation? And what can you tell us about the one, on the 2nd of August next year that will scrape Northern Africa? I mean, are there any particulars there? And are you in collaboration with, say, the African Space Agency? If so, what? That'd be really interesting. Thank you.
Sure, I'm happy to take that, Eva. Yeah, I wasn't sure if you heard at the beginning of my presentation. So we have a number of geometries. So we have the plane of the solar system in which the Earth, or the so-called ecliptic, that the Earth orbits the Sun. We then have the orbit of the Moon. The Moon's orbit is elliptical around the Earth, but it's slightly tilted relative to that plane of the Earth and the Sun. So it's not that we're all lined up and we just go round in circles and every now and then the Moon gets in the way. So it's that combination of geometries. Obviously, the Moon is sometimes closer and sometimes further away, whether it's perigee, whether it's apogee. When it's close in perigee, and the angular alignment, so the orbits line up. So if you imagine, it's a little bit like, you know, something doing this, and every now and then it will line up between you and me, but all the other times it won't. And then, of course, the shadow that is then cast on the Earth is actually quite a small shadow, and that's why you have a small path of totality. So they are happening at other places on the Earth. But of course, when it has landfall, and landfall particularly where people are, that's obviously where it raises the attention. So yeah, it's not that we have any sort of special cosmic coincidence happening. It's that we're noticing this because obviously we're doing this from Spain. It's where people are. We are in touch with the African Space Agency. We work very closely with them, and we will be looking to see what we might be able to help the public with next year. Obviously, our focus is on this one this year because this is big for us. It's a little bit more challenging to have large numbers of members of the public, where it will be next year. Although I know there are people who've already booked their holidays there, and I'm sure Airbnbs will be fully booked many years in advance. And obviously there are real, you know, fans of solar eclipses who have that as a hobby and who will chase them. They will go on cruises, they will travel and take their holidays wherever there is a solar eclipse. So I think for us, if you live in Spain or you live in Western Europe, that's why this is special, because it's probably one of the more accessible ones. Hope that answers your question.
Thank you. It does. I mean, just to come back to these sort of the three events at one point, I understand that there are the, you know, it takes time for these alignments to happen, but in a sense, so it's just, in lay terms, a coincidence that it's happening now, or is there a reason why? Is it just the mathematics? Is it just the maths that say
it's the
taken
geometry.
100 years for them to align?
That's right. So they happen elsewhere on the Earth, but obviously, I think it was 1912, the last one along the Iberian Peninsula, and then I think there was a partial in 1998 that went over the south tip of the UK or Guernsey, and of course there was one in the US last year. So it's just that we tend to notice this because we have landfall, and so we're paying attention to these three, but they happen elsewhere on Earth. But as I say, it's that alignment, and so it's you're starting to move off that alignment within the space of about 18 months. So it's expected that you would have some close in time. If we were obviously at the edge of land, and then the next one was in the middle of the ocean, we probably wouldn't be having this conversation.
Right. Thank you very much. Thank you.
Many thanks, both again. I believe Niam Show from the Irish Time is.
Yeah,
Hello,
thank you. Back again. Sorry, it's a sunny day in Ireland. It's amazing. We're having a heat wave, so stay to me. But anyway,
enjoy it.
Two very quick questions. So Iceland is going to experience totality. So I would love to know, are you expecting to see aurora at the time of totality? And if so, is there a live stream of that? Because that would be amazing. And do you have any experiments on the ground in Iceland if that happens? Because a few people have asked me that. And then secondly, I mean, I don't know if you planned this at the time. I don't know, but is it, would the ISS be flying over at any stage during totality across Europe? And if so, will we be able to see that? Maybe not live, but eventually afterwards. Thanks so much.
Great questions, Neem. First of all, for Iceland, I think it's a really good question on the aurora. We have a mission that we launched in May called SMILE. This is a Chinese ESA mission, joint 50-50, and we launched it on the 19th of May, and it took us about a month to get it into its science orbit, which is about 121,000 kilometers above the Earth. And the purpose of that mission is to study the Earth-Sun system. And so we have 45-hour continuous monitoring of the aurora in the optical and the ultraviolet, and we're also imaging for the first time in the X-rays the so-called magnetosphere and the magnetopause. So this is where if there is a solar flare or the solar radiation particles hit the magnetic field. So we will have an absolutely amazing view of the Earth from that high distance, should that happen. I don't believe we have an experiment on the ground, although I'm sure our Icelandic colleagues will be out in force monitoring that. Some of the challenges, obviously, we're hoping that colleagues in Iceland will have a clear view. If you use the polar Earth observation missions and actually just look at the history of cloud coverage of various sites where there'll be totality, you obviously need a clear sky. So we're keeping our fingers crossed for them, but there are some sites where the cloud cover may be, the probability of cloud may be 60 or 70%. So again, we're keeping our fingers crossed for everybody that'll be clear skies. You clearly have clear skies in Ireland today, so that's wonderful. But so yeah, I think as the sun, the light is blocked out, you get a view of the night sky for a minute and a half or 30 seconds, depending where you are, which is also really remarkable. Suddenly you see the night sky. So I think we're planning for what we can see. We're hoping to predict what we'll see, as Miho says, to test our models, and I think we're also open for wonderful surprises.
Thank you. That's great. Thank you. Fingers crossed for clear skies in Iceland then. Thank you.
Absolutely.
Thanks, Tim. Marcia Dan has an additional question.
Yes, could I a couple more Proba 3, please? You mentioned that Proba 3 has created a few hundred eclipses. Do you have a more specific number? And what is the longest eclipse that you've created with Proba 3? And will this be the first time that the spacecraft actually observes a real eclipse, not just artificial? And for Miho, one more, will this be your first total solar eclipse?
Thank you for the last question as well. So just to start, so the duration of an artificial eclipse made by Proba 3 is actually bounded by its orbit. So whenever we have this formation flying where we have those two spacecraft that are aligned in order to do coronagraphy, we are bounded by how they are orbiting around Earth, and we are bounded by 6 hours. So we cannot go longer than that. That's what we call the apogee arc, where we're looking at the sun during that time. So unfortunately, we cannot over this coronagraphy orbit go beyond that. In terms of space, I don't have I don't have the top of my head the number of eclipses, so I'll be happy to contact you, or you can email me as well if you want the exact number, because I don't want to give a false one. And you had. Did you have another question?
Will this be the first time
for me? Yeah.
For you and for Proba 3?
Proba 3, yeah. So for Proba 3, this is the first time indeed that it is going to be looking at the sun during a total solar eclipse as seen from us. That said, just to be careful that, again, we are constrained by orbital dynamics. Currently in the plans, what we can do with Proba 3 is we can have an artificial eclipse 12 hours before the total solar eclipse occurs on Earth. We cannot, because we're going to be actually behind the Earth, we cannot look at the sun during the total solar eclipse. So in that sense, we're going to be the closest Proba 3 has ever been to a total solar eclipse, but we're not going to be observing during the total solar eclipse. So just to make sure that this is understood.
And then yes, so you're saying that Proba 3 will be on the opposite side of Earth during totality.
Exactly. So it's not exactly opposites, but we're going to be observing the sun. So we have this alignment. So our artificial eclipse, where the moon is actually our second spacecraft. This is happening in the morning at around 8:30 UTC, and then it's going to lock out from this specific orbit where we can do coronagraphy, and then go into its behind the Earth's part of the orbit. So we don't have co-temporal observations. That said, it's still 12 hours ahead, which is really interesting for us.
And if I may just add,
yes.
sorry, Miho, go ahead. Yeah, please go ahead.
Just to answer your personal question, so this is going to be my fourth one, but my first attempt in 1999 was compromised. I was a young child at the time, fascinated by astronomy. Unfortunately, it was cloudy. And then the first real total solar eclipse that I got to see was the one in 2019 in South America, so I was in Argentina. And as solar and space physicists, we like to organize events during total solar eclipses. So we were there with a large group of colleagues. And I have to say that had an extra flavor because that was the first time I could see the object of my studies with the naked eye, just during the totality, of course. But it was like, that had an extra flavor for sure. And then I got hooked, and now I understand why people have eclipse fever.
And just to clarify, so I know you can get up to 6 hours. What have you come close to 6 hours with your total create your artificial eclipses?
Yes.
Okay.
So many times. So yeah, during those chronography orbit, and we do the full 6 hours.
Okay, thank you.
Yes.
And Marsha, just to add, I've added a link in the chat there for you. So obviously Miha will come back to you with more up-to-date numbers, but this was an article that we published back in April that you may have seen. So defining an Earth-based solar eclipse is somewhat, I guess, artificial in the sense, how long is a solar eclipse? You know, you can take the number of hours that we can make a partial, an artificial solar eclipse, and then you can divide by, I don't know, 1.5 minutes or 6 minutes, or the typical average time of a terrestrial natural solar eclipse. But we estimated they're about the equivalent of 5,000 if we had to observe these naturally from the ground. So it's quite an impressive mission.
Many thanks all. We are 5 minutes away from finalizing this call. I don't know if there are any remaining last-minute questions that you would like to ask our experts today. In any case, yes, Nim?
Just very quickly, Carol, where will you be for the eclipse? And have you seen
I
many?
will be. No, it will be my first. I will be up at the Alhambra Observatory at Teruel. So I will be on the broadcast with Dame Maggie Aderin. So we'll be talking about the science and everything leading up to it. And then I'm hoping that we will get the chance to run outside, observe it. We may not be talking through that moment. So that's going to be really exciting. So I'm a little bit nervous. I'm very excited. We'll be working, and then hopefully we'll take that moment for 1.5 minutes to go and observe it. Fingers crossed for clear skies, and then back in to continue with the broadcast to finish the program and share the excitement and the follow-up. So yeah, lot to think about.
Have you seen an eclipse before? You've experienced them before?
No, I've seen partial solar eclipses and lunar eclipses. If actually there will be a lunar eclipse after the solar eclipse, but never a total solar eclipse. So I'm really excited.
Yeah. Okay. Thank you.
Thank you.
Thank you all. Okay, thank you. Thank you very much all actually for attending. As we were mentioning before, any remaining other questions that you may have afterwards, just write to us at media@esa.int, and we will be very happy to take them forward. We will be, this recording will be made available later today and later today on our website. And thanks very much everyone for joining us today. Have a good day.
Thank you.
Thank you. Bye-bye.
Thank you. Bye-bye.
Thanks. Bye.